Okay, everyone. Hey, welcome, guests and panelists, to the third session of our Master's Series. We truly appreciate the partnership and sponsorship, certainly of the Rutgers Business School and the Masters of Science in Supply Chain program. Thanks especially to Rudy Leshner, director of that program, and Brody Sheldon, who is the senior program coordinator. If anyone has questions about the master's program, please reach out to Brody and Rudy. All right, well, I'm Sunny Nastasi. I'm happy to welcome you as the MC of this forum on artificial intelligence in the supply chain world. We know you have some questions as well, so please use the chat function. I'll be monitoring the chat throughout the session here. And toward the end, at about 10 minutes before the top of the hour, I'll go ahead and pull up your questions to have them addressed by our esteemed panelist. Our intent today is that you come away with some ideas or steps you can take to synergize your data science approaches or maybe help in decision-making in this arena. I've had the chance to meet our panelists today, so I assure you they are truly experts on this subject. I expect we'll have a stimulating and informative conversation. The idea is to try to bring a very technical subject to supply chain practitioners in a sharper focus. So we look forward to the conversation and also your questions. Also note that we're going to be sending you a survey after, so please give us some feedback. You may offer us suggestions for future sessions of this kind, and we'll also send you a recording of the session. So with that, folks, let me briefly introduce you to our panelists today. Stephen DeAngelis is an internationally recognized expert on artificial intelligence and advanced analytics. He's a patent holder, a technology pioneer, and an entrepreneur. As president and CEO of Intera Solutions and Massive Dynamics, two technology services companies, his career is at the intersection of international relations, business, government, and academia. Steve, welcome.
Thank you very much.
You are welcome. Next, as co-founder and CEO of software development company Wahupa, Stefan de Kock is on a mission to utterly disrupt the supply chain domain. He seeks to make it better, more profitable, sustainable, equitable, efficient, stable, resilient, manageable, and pleasurable for all of us to work in. Stefan is passionate about math and the math that needs to be fixed, which we have been applying inappropriately in supply chain. So Stefan, welcome, and we look forward to your comments.
Thank you very much for having me.
Finally, Bob Ferlauto, who serves with me on the Masters of Supply Chain board at Rutgers, will be your host. Bob is a senior operations executive with more than 30 years experience transforming and integrating operations and end-to-end supply chains. He has made major contributions creating value in roles spanning the supply chain continuum and is currently Chief Operating Officer for Avant Bio, an early stage biotech company. Thank you very much, Bob, for being here too, and I'll hand it over to you now.
Fabulous. Thanks very much, Sunny. And again, welcome to all those who are joining us this afternoon, including our distinguished guests, Steve and Stefan. I'll remind you, we'll hold questions till the end, and we'll ask you to post your questions and use the chat to post them, rather. So Steve and Stefan, how are you today?
Pretty well, thank you.
Doing great.
Thanks very much for taking time out of your busy schedules to join us. And I know you're in different parts of the country, and you know a little bit that I'm always interested in the weather, and I love sunshine. I miss sunshine in the winter months. And you know, you guys are data scientists, so I was hoping that you still haven't told me, but I was hoping that you give me some insights on some tools I can use to better predict the weather, but we'll get to that towards the end. So to frame out our discussion about data science and the potential powerful synergy with management processes, I constantly think about the compelling book and movie Moneyball. Now, if you haven't heard about Moneyball, it's the true and amazing story of how the low-budget Oakland Athletics baseball team were literally transformed from a chronically losing team to winning the World Series by utilizing data science to make key decisions. And for me, this was the first real compelling example of how data science can literally transform organizations, make underdogs into winners, and change the game, so to speak, by melding data science with management processes and decision-making. Since we're at the precipice of doing this in our supply chains and extended organizations, I thought the time was right, Steve and Stefan, to obtain insights from the two of you who are both pioneers and thought leaders and forging your way forward in this area. So I assume the two of you have seen or read the book.
Yeah.
Yep.
Cool. Yeah, good book. So again, if you haven't read the book or seen the movie, I encourage you to do so, especially if you're interested in this topic. So to start, Steve and Stefan, why don't you tell us about your companies and your areas of focus? Stefan, why don't you go ahead? Stefan, why don't you start?
Oh.
Okay. Yeah. So Wahupa focuses primarily on probabilistic probabilistic models and algorithms, and applying that to supply chain problems, forecasting, planning, optimization in the areas of demand, inventory, manufacturing, distribution, supply, and so forth. So we believe that's the only way to deal with uncertainty in real supply chains, in a nutshell.
I'll tell you about Intera. Intera is in Master Dynamics. We are what we call an autonomous decision sciences company. So think about the next step of the data science journey, where the human-like reasoning AI engages with mathematical engines to solve problems and optimization and problems and analysis along the value chain of companies. And we try to build a system of intelligence that goes across the transactional systems of record to allow us to unlock value that has previously been bottled up across the value chain. We call that end-to-end value chain optimization and decision-making. And we do that with large and mid-sized companies, principally in the global consumer goods and retail industries.
And Steve, just a question relative to that, to end-to-end value chain optimization. Are you extending beyond the company itself that you may be working with?
Yeah, I mean, so the area of science that we play in is an area called complexity science. And we think about it as the analysis and control of complex dynamical systems. And so the ecosystem of large consumer products firms, is a broad ecosystem that could consist of their consumers upstream and their suppliers downstream and their transportation and logistics players along the continuum of the value chain. So yes, it is for us defined as an ecosystem.
Great. So when we think about Wahupa, when we think about Intera, what do you consider to be the strengths of your underlying technology and the models that the technology supports? If you haven't already discussed that, I think you touched a little bit on it, Steve, but do you want to expand around some of the strengths of the underlying technology and how they support your models?
Sure. I mean, we have a history as a government contractor, and we came out of government sector where there was a lot of data to analyze, and we needed to gain scalability in the analysis of data. So one of the things that we tried to do is bring together three components of a platform that have historically been disconnected or focused on in silos by practitioners. So we brought together a human-like reasoning AI. So we don't define AI as a machine learning algorithm. We define AI in the area of computer science called semantic reasoning and symbolic logic. So it's mathematical logic that allows you to forward chain and backward chain logic to reason in a human-like fashion. We combine that with the second piece of the platform, which is a glass box, transparent, explainable machine learning capability. That instead of a black box that generates a pattern, this is a glass box that generates a function or a combination of variables in primary, secondary, and tertiary level interactions that are explanatory to the data that we're investigating. That's really important if you want to build trust with people who are using the data, because they want to know what's happening inside the analysis. And that then sets up the third piece, which is a real-world optimization capability that allows us to do what we call nonlinear constraint-based optimization. So our platform consists of three pieces: human-like reasoning AI, glass box machine learning, and a nonlinear constraint-based optimizer.
Cool. Interesting. Stefan.
Yeah, same question. In a nutshell, what is the strength? I would say it's not fundamentally flawed compared to all the traditional methods. So what we do is
Tell me more about what do you mean by not fundamentally flawed?
I was going to do that. So we model uncertainty. So we don't fight it. It's like, I'd rather be the guy standing on a surfboard on the wave rather than the guy in the surf trying to hold the wave back, if you will. And that's really the difference between the two models. So if you think about traditional models, they output time series of exact numbers. Next month we sell 100, month after that 110, and so forth, and the same with all your plans. And the internal workings are all calculations on exact numbers. So what we do is we consider everything that's uncertain as probability distributions, and that's both our outputs, but also our internal calculations are all working on probability distributions. Anything that's uncertain. So that's fundamentally the correct way to model the real world or real supply chains. So where the traditional models are precise, they tend to be extremely inaccurate, whereas probabilistic models are highly accurate, but they tend to be imprecise. So it's a true opposite paradigm, if you will. Now, as Reed Carfit said over 100 years ago, it's better to be roughly right than precisely wrong. And that's really what this concept is all about.
There you go. It's amazing to me, just some commentary, as we all work in supply chains and organizations, supply chains especially, is such complex systems. And many of the tools that are still being used are deterministic, like giving one answer, as opposed to taking this probabilistic approach, looking at probability densities and so forth to kind of give a range of possible outcomes that people can then better quantify and then perhaps use in better decision making. So very interesting. And Steve, let me go back to one element that you mentioned, which to me was always interesting, is whenever companies would invest in new technologies, it was always kind of, they give you a little flavor for what it's all about. Trust us. And then you're dealing with these black box algorithms within this black box. So I'm intrigued by this notion of a glass box approach or glass box module. Can you talk more about that?
Yeah, I mean, one of the things, like I said earlier, the goal in mathematical analysis is to understand what is happening in the data. Data science is all about extracting meaning, and in our case, understanding from the data that you're looking at. We, like Stefan, also believe in a probabilistic, non-deterministic world, right? And the notion is that in order to explain and to simplify the analysis, you need to be able to peer into the data and find what is actually driving behavior within the data set. You want to find the control knobs, as it were, that are influencing the behavior. And sometimes those control knobs, Bob, are lurking behind a primary set of interactions. And you need to be able to decompose the analysis such that you see in, like I said before, in primary, secondary, and tertiary level interactions, what is driving behavior in that data set. And if you could explain that, you could start to build trust. And when you're looking to build systems that allow you to optimize the value chain of companies in a way that is transformational, one way to do that is to build trust with the end user such that you can explain to them what is going on. They could see cause and effect. If I turn this knob, then this happens. And if I could turn this knob, then that happens. And I could predict the outcomes based upon knowing how those variables in the data set affect one another.
Fabulous. Yeah, this notion of trust and people being able to understand and look at what is going on is so important. I mean, here we are, how many 30 years almost later with the experience around systems of record, the ERP systems and the supply chain modules within those systems, and folks are still widely using spreadsheets because they don't understand or they don't trust what's in the system, and more often, as I indicated before, they're more deterministically based rather than based on probability and probability density. So very, very interesting. Really cool that you guys are doing that sort of stuff. So in line with today's discussion, I'd like to start. I'd like to bring your attention to the following graphic with the point that it appears we're in a hype cycle relative to data science, right? Everyone's talking about it. Talking about artificial intelligence is an article every day, machine learning. And if you look at the graphic, it represents this fine balance between data science and management processes. And, you have the sphere of data science, and within that sphere, you have artificial intelligence, you have machine learning, even deep learning. And then on the right, you see what appears to be the head of a company talking to, maybe it's his chief data science officer or chief technology officer. And he says, hey, are we using artificial intelligence in our company? And the response is, well, no. We're using statistics with a little bit of machine learning. So although most feel that incorporating data science with management science is vital, there's a lot of confusion about terminology and applications. So how would you define, just walk us through how you define data science, artificial intelligence, machine learning. Steve, why don't you take a shot at that?
Sure. I mean, I think, there's AI has come to mean both everything and nothing at the same time, because it's cast a very wide net today. Truth be told, there's nothing artificial nor intelligent about a machine learning algorithm. It's a pattern recognition technology that, as a black box, does not understand what it's looking at natively. It requires a human to interpret that. To me, data science, the classic definition of data science is we want to extract knowledge and data from information. I'm sorry, we want to extract knowledge from information, right? And the difference to me with artificial intelligence is you want to extract data and knowledge, but you want to then understand fundamentally about the data and the analysis you are performing. So AI to me means the use of technologies that allow you to reason in a human-like fashion, right? And if you combined that reasoning in a human-like fashion with machine learning techniques, with statistical techniques, and there's no one tool fits every problem, right? It's truth be told, it's Stefan would probably agree. A lot of this is how do you pose the problem correctly at the beginning, and how do you design the analysis in a way that is most appropriate for the data and the outcomes that you are seeking to realize. And a lot of the skill and craft in data science and machine learning and artificial intelligence is knowing how to design the analysis properly at the beginning, pose the right question, design the analysis, use the appropriate tools, and then know how to interpret the outcome. Because there are a lot of folks today that know how to mechanically connect the data set to an algorithm, but don't know how to interpret the results that come out of the algorithm, right? So the notion is that I think that it's all about extracting knowledge from data and then understanding fundamentally what you're analyzing is the movement from machine learning and statistics to artificial intelligence. If the machine can extract understanding and it can reason, therefore it has the ability to be defined as artificially intelligent.
Yeah, good points. And I think you mentioned the importance amongst all this data and trying to gain insights is you have to start by asking the right question. And what comes to mind is the famous, I think it was a Danish scientist that worked in the early 1600s, Tycho Brahe. And he spent most of his life doing great science, asking, making great observations, but studying why the sun moves around the earth, so talk about, making sure you ask the right questions. So it's really important to have technologies that start, and people who are integrating these technologies understanding that point. Very cool. So what does the intersection of management and data science look like? Is there a balance? Are there case studies that demonstrate what good looks like when it comes to synergies between data science and management science?
So, one interesting thing was over the course of the last several years, we have worked with clients to navigate them through COVID. In 2020 it was COVID. In 2021 it was COVID plus inflation. In 2022 it was COVID plus 2 more rounds of inflation. And in 23, and it was also in 22, the supply chain ramifications of the war in Ukraine, right, affecting the agri-food value chain. And then this year is probably all of that, plus possibly a recession. And the notion is that if you posit that you can perform certain forms of optimization along various swaths of the value chain in a way that is generationally faster, and you can make decisions with a machine, with humans, augmenting humans in that process. If you posit you can do that, you could transform the way the business processes operate. So a real world example is in work that was done, the work that we have done in the area of revenue growth. The normal process of optimizing trade promotional plans between a manufacturer and a retailer in a category would take about 3 to 4 weeks at best, right? Using the type of system that we could do it in 5 minutes with 92+% accuracy. So if you look at that, right, then what happens is you can transform the way the process works, because something that was previously taking 3 weeks, right, is now taking 5 minutes. You could iterate with your retail partners in a way that allows you to build connectivity between the manufacturer and the retailer, because you can prove out hypotheses at the speed of the market and then adjust to market conditions. So when you think about that blending together, Bob, if you posit that these types of technologies are available today, this autonomous decision science capabilities, you can basically interweave management science with the technology in business processes, such that if you think of the autonomous management practice and the technology as 2 strands of DNA that get interwoven, right? Now you're designing a process with the technology as a key component of that process, and you're operating at the speed of the market without latency. So that's an example of how this worked, and it's driven outsized results with customers during periods of uncertainty that Stefan was talking about earlier.
Thanks. No, it's a really relevant example. So appreciate that insight. The other thing that comes to mind is that no approach is ever perfect. So for those eager to continuously improve, what do you think is missing in the digital roadmaps of most organizations? Stefan?
Stephen already mentioned, a big focus on people, and I think they are also the problem, right? How do you get the right people? How do you get enough of them? Because all this technology still needs people with all the foundational knowledge, with the domain expertise. And if we look at companies today, they're hiring armies of data scientists. Most of them are fresh out of university or college, and providing them very little guidance, simply because they don't have the bandwidth to do so. And all these non-experts in the domain that they're operating in, they're all making the same mistakes. So, for example, if you look at forecasting, the oldest and biggest problem it has is overfitting, right? Which is, for those who don't know, it's really where the model finds patterns that don't exist, right? They're just random or temporary behavior. It's the opposite of underfitting, where there are patterns and the model doesn't find them. But overfitting is a real big problem, and statisticians, experienced ones, are always on the lookout and actively fighting it. Now, when instead of going from the old univariate statistical methods, you're now going to apply AI, machine learning, deep learning, those problems don't go away, they explode, they become way bigger. But the data scientists that are coming out of the university, they're blissfully unaware that this problem exists, right? They'll create a machine learning model and they throw everything in the kitchen sink. Like, I have yet to find a model created by one of those that doesn't have at least 100 features in there. And all of them are noise generators. They're not actually finding patterns, right? So when I do a project, I come in and I typically end up removing 80 to 90% of all these features and maybe add 5 new ones. And then the accuracy goes up, sometimes dramatically. Right? But that's just an example, right? The problem is wider than merely features, wider even than overfitting. But I think the overarching pattern is that lack of domain knowledge and expertise that is available in the resource pool that's available to companies at scale.
Good point. Yeah, this human factor is huge. In fact, it might be said that imagination, not necessarily intelligence, is what makes us human. So this notion of imagination, which is something that I don't think machines, at least to this point, have been able to master, right? This notion of imagination, that's what drives progress for humans. So the point that you brought up, the human aspect of this, and really, really important. And we'll come back to that a little later, perhaps. So let's sort of frame this out for our audience. What do you think are the barriers to achieving true synergy between management processes and data science? This could be a lead-in or follow-up rather to what you just talked about. What are some of the barriers to achieving that true synergy between management processes and data science? And I'll open it up to the two of you.
I could take the first cut. I mean, I think the barrier in every engagement is, do we have data? Do we have proper access to data? So the sort of primary level barrier to a successful engagement is, do we have data and is it properly organized? So that's the sort of prima facie problem. But putting that aside, let's say we have that. It really is about leadership. It's about sort of the way that the maturity of the organization to engage the analysis and perform the analysis. And then it's the organizational structure. So if you think about leadership, is, do we have a corporate mandate, or do we have a business area mandate to break down silos, to transform a business and unlock value that has previously been bottled up? 2 is, do we have a minimum level of maturity, as Stefan was talking about, with the analyst team and the business analysts, people who can speak to each other fluently, right? You need to be able to have a technologist, say a mathematician or an analyst, be able to get requirements from a business analyst who translates it from a business owner. So you need that sort of minimum level of maturity to have that translation of problem statement to engineered solution and back and forth happen effectively. And then I think you need to align the metrics. In other words, you need to align the outcome. You need to align the metrics to drive behavior that is aligned with the outcomes that you want to achieve, right? And I think if you are able to deal with that leadership function, the maturity level, and the organization's alignment, then you have a very good chance of having a successful outcome in your transformation project at the company.
Right on. I couldn't agree more. In fact, we do these. This wasn't planned, but we do these seminars monthly. And next month, our guest is a leading expert in the area of organizational alignment, design, leadership. So terrific. That's a great follow-up for next month's topic. It's really, really important. I think as we've struggled, as we've built this whole area of supply chain management over the past, like I said, 30 years and more, we found that there is that element of leadership, organizational alignment, organizational systems that are so critical to making this a success. Stefan, anything to add?
Yeah, well, so I do agree with Stephen here, but I would put the focus of the barrier slightly different. So I know maybe if I can word it slightly different, the problem is these functional silos, right? Where different parts of the organization are making decisions disconnected from others. And I see kind of three subtypes of functional silos. And the first one being data silos. And there's been a lot of focus on that. And many companies are making major improvements, getting all their processes to run on one holistic data source, be it federated or distributed or whatever. And some are even doing that on holistic or single platforms across their business. And there's still some way to go there. On the other side, we get to the management side, there's these decision silos, as I call them. And this is where all the metrics and alignment and all that stuff comes into play. And IBP is like a major process that relies on this. And I don't think it's gonna reach its potential unless we get rid or we fix the third one. And that's sitting right in between those two, the data and the decision silos, and I call them information silos. So where data silos is removing is basically allowing the data to flow up, if you will, and information is about how's the data flowing sideways between processes. And businesses are still throwing stuff over the fence from one department to the next, from one business process to the next. One process will say, make these 100 types of widgets. And then the other process needs to decide how to make them, but there's not enough capacity. What do we do? Which of the 100 do we reduce? What blend? Or maybe we've got excess capacity. What from the next time period are we bringing forward? It doesn't know, right? It has no clue. So what happens, it needs to go back. It makes some assumptions. Next time it goes back, another planning cycle is gone, and you lose a lot of time. And in the meantime, errors are made, right? So what you actually need, going back on the probabilistic side, is you need probabilistic data. You need to know not just what's that one number you want. You want to give ranges and valuations of every value within that range. How desirable is it if we go 10 over on this widget? How desirable is we go 5 below on the other one, right? And that's the you need that kind of information to flow between processes to really make these two sides work together. That's where I think is the biggest barrier so far. And I think it's because it's not recognized fully yet.
Oh, fabulous. And I knew there was a reason why I follow both of you guys and really admire you. No, really good. Sonny, let's make it a point for next month's session to really dig into how to design to try to eliminate these organizational silos, because to Stefan's point, it's a challenge that exists to this day, and I'm not sure many companies are doing a great job.
Absolutely.
Silo busting, so to speak. So let's make it a point to do that.
Mhm.
All right, guys, something a little different. So a recent survey that I read within companies has shown that almost 70% of individuals that are actively involved in digital transformation are actually very disenchanted with their approach and their journey in digital transformation. And many have referred to their efforts as a mess. Why do you think that is? And where have they gone off the tracks?
Like me to go first?
Sure.
I think that, from what I said earlier, a lot of I think, again, I haven't been exposed to many that have gone off track. So, but the ones, what I have heard is that the problems were ill-formed at the beginning. In other words, you're not forming the problem correctly. And then if you don't have a formed problem correct, your project is going to not reach the outcome that you want it to reach. I think secondly, you have this siloed effect that both Stefan and I were talking about, is that you have people who are entrenched incumbents inside a company who don't want to change. They have a particular job that they do well. They have a craft that they do well. They have functions that they do well, and that the data science project or the transformation project they perceive as a threat, versus them getting invested in a new set of skills to raise their performance level in the company. And then I think there's a problem with selecting the wrong technology or the wrong analytic tool to solve the problem, right? And I think that is something that comes from folks not being fully grounded in data science and knowing what tool to use against a properly posed problem, right? And I think those are the types of things, one is we didn't form the problem correctly. We didn't design our analysis. Two, we may have selected the wrong tool, even though because we may think it is the right tool, but we don't understand enough about the analysis to determine if it's the right tool or not. And then I think a large part of it is that people don't want to change. They're entrenched in their role, and their role is not, and they don't perceive alignment with their career success with the transformation effort. So I think those are some of the things that, from anecdotally what I have heard are things that are problems in digital transformation efforts.
Okay, so again, more organizational. I mean, there's some technical aspects, but a lot of organizational. Interesting.
Well, I think really, Bob, you can't underestimate the forming of the problem correctly at the beginning. It is a really difficult thing, because when you use data science, you need folks who are trained in the scientific method to actually pose the data science problem, take the business question and pose it as a data science problem, right?
Yeah,
And
avoid the Tycho Brahe effect, like we were saying before, right? Ask the right question.
Right. That translation process is not easy. I mean, it requires skill, right? And so, to Stefan's point, a lot of younger folks haven't yet been apprenticed in the work. They haven't been nurtured. They've come out of school with great technical skills, but we need to train them with a business manager to understand how these things translate. And I think that's a little bit of the challenge.
Absolutely. Stefan, your thoughts?
Well, I can't disagree with any of that. And I think that is probably the number one. But on the technical side, and especially on that building the model side up front, I'm going back to try not to be precise at the expense of being accurate. And that's not just about the numbers. This is, trying to find the optimal solution to an oversimplified model. For example, now you get the most optimal solution. You had a mixed integer linear programming algorithm tell you that it was the most optimal solution, but it happens to not be feasible in the real world because the problem was stated incorrectly, or something that might be recognizable to a lot out there, the single version of the truth, right? The concept sounds really cool, but most companies go overboard, right? They lose the distinction between aspirational plans versus how you're going to get there and things like that. So we're trying to be very, very precise. We're even being dictated from above to be precise, give an exact answer, give a one number answer. And I think that's actually preventing the people that make these systematic thinkers, these scientific thinkers that Stephen was talking about, preventing them from actually delivering the right solution statement or problem statement, if you will.
Okay. What comes to mind for me, and I just like your perspective on this, is, you have this, the agreement in an organization is we have to digitally transform ourselves, and let's put a plan together to do that. And then what I've seen is this duct tape effect. You know what I mean by the duct tape effect? Everybody knows that terrific, versatile stuff that comes in different colors that patches everything. And then people start to try to put these let's put technology here. Let's put technology there. Seems to be probably the wrong thing to do. No, is that more organizational?
It's missing some WD-40, I think. it's not just enough to strap things together. You also need to grease a lot of things and a lot of parts there.
One of the things I saw over the last, let's say 7-8 years of the digital transformation wave is that the best run companies, the ones that use this well, have done a couple of things. They have focused transformation efforts on things that matter. So they've looked at key parts of the business and they said, if I can transform this part of the business practically, soberly, right, without trying to do something that's more science fiction than reality, right?
Mm-hmm.
If I focus on that and I make sure that I over-rotate on the success of that first journey, the first step of the journey, then I build off of that to the next step of the journey. And success begets success. And I think that a lot of these projects have been, like you said, I think you said earlier, like a bright shining object going past a business person's eyes, and they said, wow, there's this bright shiny object. Let me jump on that, right? And what I learned from, and I learned this observing, quite frankly, one of my colleagues at a very large consumer packaged goods firm, who's an extremely gifted guy, coaching me on how to focus on the business applications that matter, executing with excellence, because we've got to build trust at the beginning. And once we build trust, we can build off of that for the next application. But choosing the right application that's aligned with the business outcomes is extremely important, because when you do that and you're successful, people don't have the option to say, so what? They say, how much more can I get? And I think that alignment, again, all this comes in because all these things that Stefan and I are talking about technically all function within a thing called a corporation, right? And that thing has people and processes and investors and shareholders. Everything you're doing has got to be thought through the prism of how am I going to create value and align that value with the outcomes of the business. And if I'm successful, then you want the senior managers to say, how do I get more of that? Because it's helping me drive transformational value at my company, rather than I did something over here, and if it was successful, so what, right? So I think that aligning with the goals of the business and then focusing on problems that matter and then really concentrating to over deliver the early ones, I think is critically important.
Absolutely. This notion that you bring out about testing and learning is so vital, especially in supply chains, which, as I said, are such complex systems. When you implement something, you perturb the system a little bit, and you have to go very slowly. So this notion of building upon things that you learn as you go, it's go slowly. My recommendation to folks who are young and haven't experienced, working through processes, working through challenges, especially in supply chains, but in organizations overall, go slow, test and learn. Don't ever do a big bang, because you'll end up with many problems, and avoid the duct tape effect. Yeah.
Hey, Bob, we had a really interesting question come in that's salient to this discussion. May I?
Sure, please. Yeah.
Okay, so the question really asks for our panelists, how have you seen people do really well in sort of tackling this issue, taking the digital transformation and saying, how does it fit within a culture and a mindset to move the organization forward toward more data-driven approaches? So this touches upon the subject that you gentlemen were discussing, but he's really asking, hey, what are some ways that this has been done successfully? How do you tackle this idea of driving culture and mindset? It's in the sort of superordinate system, and it's apart from the data bits and bytes. Have you seen organizations do that well? And if so, what can you share with our audience?
Personally, I've not seen it done well often. But as so many things in organizations, it starts from the top. And, if you have a culture of cost accounting, you're never going to get there, right? You really need to have an organization that is willing to be flexible, rather than one that tries to fit everything into the same box. And it starts at the top. Unfortunately, I've not seen much success.
Yeah,
Luckily, I have. um, and but
tell us, Steve, tell us.
But the way that it happened was organic, right? It wasn't. So the top down that Stefan talked about is critically important, because you need the executives to give air cover to the people to take transformational risk, right? But the way I've seen it happen is where the analysis that was done. So old school, let me set the stage a little bit, okay? You have a technology analytics group within you have an analytics team, advanced analytics team, and you have people who are involved in business functions, right? So consumer products firms engaging retailers. The way I've seen it is that it wasn't a imposition of the gear on the people. It was the presentation and the trust building through the transparent engines I mentioned earlier, explaining how this works, and having folks be able to engage their trading partners in the ecosystem you asked about earlier, Bob. So you have a retail account team engaging with the retailer, and the retail account team is starting to build trust with the recommendations that the system is making, because you make the recommendation, you say the 8 ball is going to go into corner pocket, and it goes into corner pocket 90+% of the time. They build some trust. What happens then is that they start presenting that result to their trading partners with the good results. The trading partners start coming back to the company saying, oh, by the way, you could do this really quickly. I have a hypothesis. Can you prove it? Help me prove it, right? And the way it worked, Sonny, was that it was organically built. It wasn't like there was no doubt executive sponsorship at the beginning, Stefan. But what happened was the trust in the analysis started to build connectivity, started to build positive outcomes, and then they started to pull. So it moved from, it wasn't a push to the team, it was a pull from the team to the analytics, saying this is working, this is a competitive advantage, we'd like to do more of that. And I think that's the way that I've seen it work organically, come up from the bottom after there was initial air cover at the top.
Mm-hmm.
Right. And it sounds like you're also saying that there's a bit of, if we'll pardon the word, a bit of promotion going on, where there was transparency of the process and messaging that's sharing success and sharing how the thing is going, so that people can sort of grab onto it, recognize it, feel comfortable, and build that trust.
Well, so you have business people who are doing something a certain way successfully. So it's right. So now you're saying to a successful person, I'm going to give you a tool to do something more successfully. They're going to inherently be skeptical, right? So as a result of that, the only way you lower the resistance is you start to build transparency. That's why the glass box nature, the explaining how these things work, and explaining things in a probabilistic world requires a bit of explaining. And then if you're able to get people to trust the system and they see positive outcomes, then they start to see cause and effect, right? And if the effect is increase in profit, increase in connectivity with critical ecosystem partners, then they're going to want more of that. So the teams that are already well performing want to perform higher, because now they have a reliable tool that they could use.
All right, thank you so much. So it's about time to go to Q&A anyway, and we actually have had a really interesting question come in. I think,
Sonny, if I could just interrupt 1 second. So I'm sorry, we have 10 minutes, right?
Mm-hmm.
There's one question I really would like to touch on that maybe wraps us up, and maybe I'll try to go through it quickly, and then we'll go to questions if you don't mind. So why don't we try this? So, but I'm struck. I think this is important. The reality in our new world of this of digital science, supercomputers, quantum computing, sensors, smartphones, the connected devices, and progress on B2B interface technology means that there's more data than ever. And we used to hear about big data all the time, right? Big data. But does it also mean that it's getting easier to make well-informed decisions? And, you know, we're all tasked with predicting the future in an environment of ever increasing risk and complexity. So what do you make of this? Stefan, why don't just get your perspective on that?
Well, you mentioned a couple of things, and I think quantum computing, you know, it just has mind-boggling potential. And some of the other things, you know, also have great potential. But you know, there's this saying that with great power comes great responsibility. And you know, my recurring theme is just get the basics right, the foundation. You know, overfitting will get dramatically worse still, you know, if you don't actively curb it. Explainability, what Stephen was talking about, will become even more important, right? And it needs to answer not just questions like, how did we get to this answer? It needs to answer questions like, oh, this caused a catastrophe. You know, why did it happen and how do we prevent it going forward? Because if you don't understand what drove that, then how are you going to use that same tool again? Right. And I think, you know, most importantly, we got to get better at modeling the reality closer. You know, don't try to get the same bad results faster, you know, try to get better results.
Good point. Yeah. All right. So I you know, there's so much to touch on in this topic. I think we've had a really good discussion about some of the ideas, challenges, barriers, etc. Yeah, so I think, Sonny, I'm sorry for interrupting. I thought that was an important point to touch on. What questions do we have from our audience?
Well, I think one's really interesting and very practical. You know, Stefan, you brought up earlier this issue of overfitting and really domain knowledge from, you know, young practitioners who do not yet have the kind of experience to contextualize formulating problems and dealing with the interface between the technology and then the business realities. This question says, you know, really to this point, how does a recent graduate go about getting their feet wet and getting engaged in learning more and becoming a more sophisticated participant in this transformation? What practical measures might you offer this questioner?
Yeah, so I think there's two sides, two gaps there, and one is just more technical knowledge, right? A lot of data scientists don't really have a complete grasp of statistics, deep grasp of statistics, and so they definitely need to know both sides of the equation, you know. And from the statistics side, they'll at least learn to recognize the concept of overfitting and, you know, what is traditionally being done to combat that. But then also, you know, need the domain knowledge. So if you're a junior and you're looking for a job, you can definitely focus on the statistical side, just to, you know, make sure you expand your boundaries a little bit, just in the technical. It's a little harder to get that domain knowledge if you're not actively working on real world problems, right? So if you're a junior and you've already been hired into a company, you know, if you're not actively getting access to people and to problems where you can apply that knowledge, you know, proactively ask if there's places where you can learn that stuff on the job.
That's great.
Look for mentors.
Yeah. Stephen, anything to add?
I agree. I think that, you know, one of the things is that business people need to be intellectually curious. Business students need to be intellectually curious about technology, and technology people need to be intellectually curious about business. And I think that intellectual curiosity and self-learning and mentorship, as Stefan was saying, is absolutely critical. I think that companies are, quite frankly, very receptive if a young person wants to be mentored, right? I think that there is I would imagine that there is a subset of folks wanting to be mentored that is smaller than ones that are not seeking mentorship. So I think the competitive, you will find warm reception in many companies, if you're a technologist that wants to be mentored in business or vice versa. It's just finding the right person inside the company who's willing to do that. But I don't think that's going to be much of a challenge, because companies that I know are seeking folks like that.
And if you're not getting a warm reception, you may be in the wrong company.
Yeah, a good point. That's what I was going to say. I mean, to that end, I fully agree. You know, if you're, don't wait for some sort of formal mentorship. Seek a mentor. Find somebody who's willing to do that. And the second element that you guys discussed is really take cross-functional assignments. That's where my horizons were blown wide open. I was fortunate to work for a fabulous company for many, many years that encouraged cross-functional assignments. And look, I went from science and technology into operations and supply chain. So over the course of my career, and it just brings just an incredible amount of insight. If you're really seeking to constantly create value in companies. So seek mentorship and cross-functional assignments. Yeah, absolutely.
And if I can add one more thing to this, no real problem has ever been solved by sitting behind a computer screen. Go and see it for yourself, and then think about how you're solving the problem.
Great point.
Okay, I appreciate it. Thank you very much for that question. We have another. This is really a provocative one. I'll read it to you. A huge issue in Europe right now is the lack of ammunition being provided to Ukraine. The manufacturers are not able to keep up with the demand. Could AI at the manufacturing level have predicted the demand surge, or is this situation too extreme to have been detected by AI?
So,
Go ahead.
yeah, I'll do a quick one. So my opinion is not at the manufacturing level, no, but could the potential of this war happening be detected? Yeah, I think, and I think many people did, but people being not really rational, they ignored it. Right. And I think an AI would probably have rightly said, like, your risk of something happening and that you need more is significant. You should do more. And then the question is, would people have followed that advice? I still think no.
This is the type of a scenario that one of the things that we spend a lot of time on with companies is understanding how to build structural resiliency into the company. And one of the most prevalent areas of work in the last several years has been creating an anticipatory analytic that would allow you to anticipate risk, that you can't predict every risk that's going to come to the company ahead of time, but you could understand the envelopes, the probabilistic envelopes, that something might happen, and these are not hard to figure out. And then once you figure that out, then creating scenarios to pre-plan as to how to handle that is something that is being done today in the business setting, and it has always been done in the government sector, in the military. But bringing those things to life in a system approach is this concept of enterprise resiliency and competitiveness that is probably the biggest area of focus of our firm and in the companies that we work for.
Yeah, I would add one thing in that systems are not really well at responding to gaming, right? And in this case, you have a Putin who may have been posturing, right? Or he may have been serious. How does an algorithm figure out which of the two with which kind of probability? Right? There's a lot of situations of self-fulfilling prophecy or self-denying prophecies. And that's something that, why the creativity, the imagination of humans plays a part. And it's still a part where systems are lacking a little bit, I think.
That's where Stefan, I totally agree with you if you're thinking about the mathematics side of it. But on the human-like reasoning side of it, inference engines, actually, that's what they're good at. And so you and I should have a chat over a dinner one night and talk about how that could work, because I think we both find it interesting. But thank you, Sunny, for that question.
Definitely.
Yeah, very interesting. Thank you.
Honey, just what? So we're almost at the top of the hour, and I just wanted to give our terrific panelists a chance to kind of restate, sum up their thoughts. Again, we're talking about data science and the balance with management processes and management and decision making, and their impact on driving responsiveness and resilience. So responsiveness, if you think of responsiveness as acting, and then resilience as the ability to recover. Do you guys have any final thoughts on the topic and key points that you might want to reiterate?
So my, everything pretty much has been said, but yeah, hire the right people, educate them, keep educating them, and, don't fight uncertainty, work with it, preempt it, and model the real world as close as you can. You got a fighting chance.
Transform uncertainty, right?
Yeah,
I think you want to use uncertainty
exactly.
to be able to drive enterprise competitiveness for your organization. And on the resiliency side, Bob, I think it is resiliency by its nature goes beyond a responding. It is being able to anticipate what's going to happen so you are well positioned to take an action. And I think that firms that are systemically or who build an approach to resiliency as part of their senior and mid-level management layers are ones that are going to drive enterprise competitiveness, because they're going to anticipate some of the problems. They're going to be able to mitigate a risk or quite frankly exploit an opportunity when their less than nimble competitor can't be as structurally responsive. So I think you're going to see the best run firms driving towards enterprise competitiveness and resiliency in a structural way throughout the organization.
Great points, guys. Great points. Thanks so much for a terrific discussion on a topic that's very complex and full of emotion if you're involved in the digital transformation of any sort. And for our audience, I know that they've come away with some critical insights. I know I have. And for those in the audience, again, we've been speaking with Steve DeAngelis and Stefan de Kock, thought leaders in this area and heads of companies that are making their way through this really, really important arena of digital science and melding with management science. So I'd really invite everyone to join us next month. I believe, Brody, it's March 9th is our next seminar. And again, we're going to be talking about this important area of organizational alignment and leadership. And I look forward to everyone joining us next month. Thanks so much.